In this lecture, we discuss some of the basic techniques in Python for file processing, especially when accessing data in text files. A text file is any file containing only readable characters, and a file of such may contain letters, numbers, and other symbols in English or other languages. A scientific article is an example of a text file, where you may encounter math equations and symbols with special meanings. It may be a web page with HTML code which follows a special syntax defined by the W3 consortium. It may contain descriptions in paragraphs and data in tabulated structures. Text files can be viewed and edited by any text editors, such as Notepad on PC, TextEdit on Mac, or VI on Linux, Unix. But binary files require special software to access them. In this lecture, we focus on processing text files. The example here reads the entire content of a file. The open function creates a file object, a way of getting at the contents of the file, which is then stored in the variable f. Then you use f.read method to tell the object to read the full contents of the file and return it as a string. The example here reads a file a character at a time. This calls the read function with parameter value 1, which specifies the maximum number of characters to read from the file. When it reaches the end of the file, the read method returns an empty string and ends the while loop. It is very common to read a file one text line at a time. Here the code calls the readLine function to read a line at a time. When it reaches the end of the file, readLine returns an empty string and terminates the loop. Another alternative shown here is to read a file and loads all text lines. Here the readLines method reads all the lines of a file and returns them as a Python list. You can create a loop to go through the list of lines. The strip method here removes leading and trailing characters, the spaces by default. With the option W, you can open a file to write. All existing content in the file will be overwritten. If you only want to add new lines to the existing content, use option A to append. W plus create a file if it does not exist yet. R is a default option to read from a file. It is a good practice to close the file in the end with the close method. The print method writes a text and adds a new line character at the end by default. The write method, however, does not do that by default. So if you need a new line character, you have to include the /n manually. Here are a few examples for you to review and to recap what we have discussed so far. To open a text line with the R option, to read the entire content of a text file with .read method, to read one line at a time with the readLine method, to read a list of lines into a Python list, to write a text line to a file to replace what has already been there in the content, to write multiple text lines to a file with the writeLines method, to append a string to a file with the A option, and finally, remember to close a file after you are done with it with the close method. Now that we can write text files, there are a lot we can do to process data in the text. The example here is a survey about the types of radish people like. In this survey data of Radish votes, each vote is recorded in the format of the name of the person followed by the name of the radish. And there's a delimiter, hyphen or minus to separate the two. In order to find out the counts and basic statistics of the votes, such as to find out what are the most popular radish, we need to do some computation. So first, we read the file one line at a time with a for loop. The strip method removes the leading and trailing spaces in the text line, and then we split the text line into a list of two parts, name and radish, with the delimiter minus or hyphen. In Python, you can assign a list of values to multiple variables. For example, you can assign 1, 2, 3 to variables A, B, C. So when you split something into a list in Python, you can assign the result directly to multiple variables, like this. Now back to the radish survey. The code here counts the number of votes for specific radish, such as white icicle. It initializes the count as 0, goes through every vote line in the data, and whenever there is a match, adds 1 to the count. Now, this does the job well. However, if you want to count different kinds of radishes, the code is not very reusable. We can put the code into a function such as count votes, with the radish parameter to tell the function what to count on when we call it. So now with this function, we can call it multiple times for different radish types. Still, calling the function requires your knowledge of what radish might have been voted for in a survey. Perhaps it's easier to count all the votes in the survey, and whatever radish appears in the survey should be included in the final counts. One specific data structure we can use here is dictionary, which can help us keep track of radish names as keys and their counts as values. First, as you can see, in line 2, we create an empty dictionary to keep track of votes. Then starting in line 5, it goes through the survey and adds 1 to a count associated with each type of radish. If the radish has not been voted before the current vote, it has not been counted, and the key, the name of the radish, is not in the dictionary yet. In this case, as shown in code line 10, we need to add the key and set its initial value to 1. Now, if the radish has already been voted before, we can simply add 1 to the existing count, as shown in line 12. In the end, we use the print function to output data in the dictionary. Now, if the format of the print output does not look good, you may consider the pprint or prettyprint module in Python. Or you may consider rendering the output using a loop. Shown here is an example result of the program you have created to count the votes for different radishes. In the final result here of counts, did you notice the capital Red King and lowercase Red King, Cherry Bell, and Cherry Bell with 2 spaces in the middle are treated as different radishes? Apparently, when people vote for their favorite radish, they enter the names in slightly different formats. Now that we know about the dirty data, we should unify or normalize them by removing the extra spaces and converting the strings into the same format, that is, the same capitalization as well. The code here will replace two spaces with one and capitalize the names. In the end, with this improvement, the different variations of Red King and Cherry Belle will be merged. In the Reddish survey example, data are delimited by minus or hyphen. Today, it is very common to encounter data in the so-called CSV format. So let's take a look at this format and how to process CSV files in Python. CSV, or comma-separated values, is a very common way to express structured data in text files. It is supported by spreadsheet software such as Microsoft Excel and can be used to import or export data from relational databases as well. In the example here, the first line is the header with names of data fields in the CSV. Each text line after that is a data instance where values are separated by comma. You can use the CSV module in Python to process CSV files and data. The Csv Reader reads a file in a CSV format and returns each row as the list of values. The module takes care of the split of column values, so you don't need to do that again. Now that the raw variable is a list of values, you can access each value using the index. Row 1, for example, returns the value of the second column or field. We noticed earlier that the CSV usually provides the header with names of the fields. When there are many fields in the data, it is easier to use names instead of a numeric index to access the corresponding value. With dig reader and dig writer, you can access data in a CSV using column names in the header. Because CSV format is a plain text format that uses comma as a delimiter, you can simply open a file and write to it using the comma delimited style. To make sure data are written consistently according to the format, however, especially if you have special characters such as comma in the data, you may consider using the CSV writer. There are other commonly used formats such as JSON and XML, among others, and we'll discuss them in another lecture. Besides basic file read-write, Python has a wide range of tools and packages for loading, cleaning, and pre-processing data. Pandas, for example, is a very powerful library for data analysis and manipulation, along with NumPy, which makes it easier to compute data in vectors and multi-dimensional arrays, and SciPy for scientific computing.